Here we go, second half of section 8.1. We're doing compound inequalities, this time with or. So compound inequalities are greater than this and this, or greater than this or less than this. So today we're going to work with or, which means, we're going to use what's called a union. Last time we did intersections, and in order to be an intersection, we had to have every piece in the two different sets. Now, with a union, we're taking all of them. So they had to match up in the intersections. In the unions, it means everything in this one and everything in this one. So using our original example, if the set A is 1, 2, 3, 4, 5, and the set of B is 3, 4, 5, 6, 7, then the union, do you see the difference? The union is the U shape instead of the N shape. All right, then the union of A and B is everything in both. So we would have 1, 2, 3, 4, and 5 from A. We already have 3, 4, and 5 from B, and then we're also going to have 6 and 7 from B. So it's the set 1, 2, 3, 4, 5, 6, 7 would be the union of A and B. So, so the union is every element in both sets. So that means that they don't have to overlap. So let's look, and actually let's get our list here, our directions. Solve inequalities with or. Number one is just solving the inequality, just like we did when they had and. And then the second step is the solution is both graphs together. So whatever is on both graphs, you leave it. You don't have to only get what overlaps. So let me show you. In this first one, 2/3 x minus 7 is less than or equal to negative 7, or 2/3 x minus 5 is greater than or equal to negative 1. So what we're going to do is, step one, we're going to solve each inequality. So here's the first one. So just solve it as if it were an equation, but don't lose the sign. So add 5 to both sides. 2/3 x is less than or equal to negative 2. Multiply both sides by the reciprocal, so 3 over 2 makes this go away. Multiply by 3 over 2, and this cancels, giving us x is less than or equal to negative 3. Solve the other side, add 5 to both sides. So 2/3 x is greater than or equal to 4. Multiply by 3 over 2. That side is just x is greater than or equal to. This side reduces down to 2 times 3 is 6. So x is less than or equal to negative 3, or, so this is our solution. X is less than or equal to negative 3, or x is greater than or equal to 6. So there's the solution, and then we graph it. So x is less than or equal to negative 3. So equal to gives a hard end, and it goes this way on the graph because it's less than. Points that way. And x is greater than or equal to 6. So we've got 6 as another place where we're going to have an end point, and this time it's going to be greater than, so it's going to go this way. And you see that there is no intersection, so there's nothing that is shared, but because we have or, this whole graph is our answer. Everything that is in this half, or this end and that end of the graph, are solutions to our inequalities. All right, ready for another one? Let's do it. All right, so now, same thing, let's solve each inequality. We've got negative 3x plus 8 is less than negative 1, or negative 3/8 plus x is less than or equal to 20. So the same thing, let's solve it by subtracting 8 from both sides. So negative 3x is less than negative 9. Divide both sides by negative 3, and when you do that, don't forget, if you're dividing by a negative, to switch your inequality sign. So now x is greater than 9 divided by 3 is 3. And now subtract 8 from both sides here. Negative 3x is less than or equal to, what's 20 minus 8 is 12? Is that yes? 18, 19, 20, yes. Divide by negative 3, so we're going to switch our sign. So x is greater than or equal to negative 4. Positive divided by a negative is a negative. So now x is greater than 3, or x is greater than or equal to negative 4. So when we draw a graph, We've got greater than 3, so here's a 3, and it's to the right of this, and it's also greater than -4. So this is also going to go to the right. So instead of saying it's greater than 3 or greater than or equal to -4, now because they're going the same direction, this is your answer because they overlap. All right? So if they overlap and go the same direction, then find out the one endpoint, and that is your solution. All right? If they go both directions, you've got to have both with the or in between. All right, last one. Same thing. Let's solve both. Add 16 to both sides. 9x is greater than, I can't do this in my head. 3, 2, 1, 4, 5, 6. Is that 18? 9, 10, 11, 12, 13, 14. Yes, because this is negative, okay? So -34 plus 16 is a -18. And then divide by 9. X is greater than -2. Add 16 to both sides here. 9x is less than or equal to 20, 30, 45. Divide both sides by 9. X is less than or equal to 5. Draw our graph to find out where these are going. So x is greater than -2. So greater than goes this way. And x is less than or equal to 5, so it's going to go this way. So because of the or, we are including the whole thing. If this was and, then it would have to be both, and it would be in between here. But because it's or, that means that the entire graph is part of your solution. So your answer is all real numbers, or even just a big R. So either of these answers, either just a big R or write out all real, and then the graph is just all colored in. Okay? So the way to solve these is to solve each individual inequality and then graph them and then include the entire graph. So whatever is in your answer is part of your answer. You don't have to worry about it overlapping. So most of them are going to look like this. Most of them with or are going to be the two ends of your graphs. It could be possibly that your two graphs go the same direction and you have one end point. So that would look like this. Or they could have two different endpoints but go opposite directions toward each other. And if that's the case, then your answer is going to be all real numbers. So those are the only three types of answers that you can have. And I think you'll do great. I'll see you next time.